Next question is on the input-output model. The question is, the input-output matrix for two-sector economy is being given by us as A is equal to 0.25, 0.4, 0.1 and 0.1. This is our input-output matrix. If the external demand for the outputs of the two sectors is being given us as D is equal to 10 and 20, which is column matrix, we are supposed to find out the optimal levels of the two commodities. Okay, I will not go into the explanation what is meant by input output model. Here I will only solve the question. For that I will make a separate video what is meant by input output model and what are meant by the terms that we use in input output model. Okay, so we have the technology matrix or input output matrix, which is A is equal to 0.25, 0.1, 0.4, 0.1. Okay, also we are being told that final demand is 10 and 20. First thing is what we do, we form the Leontief matrix. So Leontief matrix is being formed by, we write the singular matrix minus, we subtract the technology coefficient matrix, that is A. This will be our Leontief matrix. So we have 1 0 0 1. To this we subtract 0.25, 0.1, 0.4, 0.1. So we will get 1 minus 0.25 is 0.75, 0 minus, so it is minus 0.1. Here we have also minus 0.4. Here 1 minus 0.1, it is 0.9. Okay, this is our Leontief matrix. Now next step is we need to find out, or let me rub this now. Next step is, so I minus A is this. Next step will be to find out the determinant of this I minus A, which is Leontief matrix. Its determinant, as we know, we multiply these two elements first. So we have 0.75 times 0.9. To this we subtract the product of minus 0.1 times minus 0.4. So it will come out to be, when we solve this, it comes out to be this term 0.675 and this term comes out to be 0.04. It comes out to be 0.635. If it was 0, then the system was not feasible. Since it is not equal to 0, so we have the determinant of I minus A equaling this. Next step will be to find out the inverse of this matrix. For that, first we need to find out the adjoint of this matrix. So adjoint of Leontief matrix, that is I minus A. So how do we form adjoint in case of 2 cross 2 matrices? What we do, we interchange the elements that are on the principal diagonal, okay, and we change the sign of the non-principal diagonal elements. Okay, so here we will get, so this 0.9 comes here, this 0.75 comes here. In this direction we only change the sign. If it is minus 0.4, it becomes plus 0.4. So if it is minus 0.1, it becomes 0.1. Okay, now next is we need to find out the inverse, that is the inverse of I minus A matrix. So inverse is simply 1 divided by the determinant of the Leontief matrix I minus A times adjoint of I minus A. Okay, so can we write it like this? So determinant is 1 divided by 0.635 times this 0.9, 0.4, 0.1, 0.75. Okay, Now let me rub this out. So our I minus A inverse will be equal to, so dividing 0.9, 0.4, 0.1, 0.75 individually by 0.635, what will we get? We will get 1.42, 0.63, 1.16 and 1.18. Okay, then to find out the optimal levels of output, so we use the formula, that is x, which is equal to x1 x2 is equal to, that is the inverse of I minus A Leontief matrix times the final demand. So final demand is D. So can we write it like this? D is being given us as 10 and 20, 10 and 20. So our x, which is x1 x2, will be equal to, so we have this matrix, that is 1.42, 1.16, then we have 0.63, then we have 1.18. To this we multiply 10, 20. So multiplying, so we have matrix multiplication here. Since that these two matrices are conformable, that is matrix multiplication is defined. Why? Because the number of columns in the first matrix is equal to the number of rows in the second matrix, so we can do the multiplication here. So multiplying this with this, row with column, so we get 1.42 times 10 plus 0.63 times 20. And what will be the order of the new matrix? So here we have 2 into 2, 2 into 2, here we have 2 into 1. So the order of new matrix will be 2 into 1. So we will have 2 rows and 1 column. So we need to write here next multiplication, that is 1.16 into this. So 1.16 into 10 plus 1.18 into 20. Doing this, what we will get? So our x, that is x is equal to x1 x2, it comes out to be, so here it becomes 14 point, I have done the calculation, 14.2 plus 12.6, this sums up to 11.6 plus 23.6, so we will get, adding them, 26.8 and 35.2. Okay, so this should be the value of optimal, at optimal, okay, value of x1 and x2, that is the value of the optimal levels of the two commodities.